Alright guys, welcome to section 2.4, and this is part 1 of the section. In this section we're going to be solving right triangles, and to solve a right triangle that means we're going to be finding all three sides and all three angles. We're going to need 6 parts to this. We will need to be given 3 pieces of information, and we will employ our SOHCAHTOA techniques. In all of our examples, a little side note down here, in all the examples we're going to refer to as our right angle as angle C. So let's take a look at the first example. As you can see down here, we've got our right angle already labeled. Now we're also told angle A is 32 degrees, and we don't know angle B, so I'm going to call this angle A, and label that 32 degrees, and label angle B. Now, in order to find angle B, well, that's just the case of a little arithmetic, just doing it off to the side here. 180 minus 90 minus our 32 degrees gives us an angle of 58 degrees. So angle B is 58 degrees. And just like that, we have our 3 angles. Now we need to find our 3 sides. Up here we're also given C equals 12. Well, where is side C? Side C is going to be opposite from angle C. So we've got angle C, we have our lowercase side C, which is 12. Opposite of angle A, we'll put a lowercase a for side A. We don't know what that is. And opposite angle B, we'll say is side B. We also don't know that. Now again, capital letters are used to denote angles. Lowercase letters are used for sides. So we have our 3 angles, we have one side. How do we find the other 2? Well, let's employ some of our SOHCAHTOA here. Let's say the sine of angle A, which is 32 degrees, is equal to A, or our opposite side, over our hypotenuse, which is 12. Now in order to solve for A, let's multiply both sides by 12. Get rid of those. At this point, we're going to need to use our calculator. So we'll move this out of the way so you can see. Let's go with 12 times the sine of 32. And we end up with 6.359. Now again, guys, it's important to notice I'm rounding to 3 decimal places, 6.359. So we have lowercase a, we have one part to go, lowercase b. Now, the way that I'm going to do this is I'm going to say, hey, I know angle B is 58 degrees, so I'm just going to do another sine. Sine of 58 equals our opposite, or side B, over our hypotenuse again. We'll multiply both sides by 12. Let's go back to our calculator. 12 times the sine of 58. And we get 10.177. All right, so we know this is 10.177. Now perhaps some of you noticed, hey, Mr. Lang, perhaps we could have used something other than sine. And I would say that is exactly right. If you'll notice at the beginning of this, we're not given angle B. We still could have solved for side B though, because we know angle A. So which function uses the adjacent side and the hypotenuse? That would be our cosine. So we could have done cosine of 32 equals our adjacent side over 12, done our little technique, times 12. And if we take a look at the calculator, we notice that 12 times the cosine of 32 is the exact same thing. So that would have worked just fine as well. All right, we have our side A, our side B, we are given our side C, and we have all three angles. So we have completed this example. Let's take a look at one more. Oops. One more. All right, once again, we're given angle C as our 90 degree. We have angle A as 31 degrees and 40 minutes. Oh, that could cause a problem. We like our angles in degrees. Well, hey, maybe you're saying to yourself right now, Mr. Lang, I know how to convert that. We're just going to divide by 60. We get 31 point something. Well, what is it? Let's clear that out. We'll go 40 divided by 60. All right, and again, 3 decimal places. See, it's 0.667. So we've got our angle A is equal to 31.667. So let's label these again. Here we go. Let's go with angle A, 31.667. We've got our side A, which we know is the opposite side, 35.9. We don't know our angle B, we don't know our side B, and we don't know our side C. Well, let's try solving for side B. What function employs the opposite side and the adjacent side, since we don't know our hypotenuse? Well, that would be tangent. So we're going to say the tangent of A, or 31.667, is equal to our opposite side, 35.9, over our adjacent side, or B. All right, guys, now we have to solve for B. Be careful. This is not going to be as easy as the last ones were. We're not just going to multiply by B or by 35.9 or by anything and be done. We need to do a couple steps here. So the first thing we're going to do is multiply both sides by B so that B is no longer the denominator. So now we've got B times the tangent of 31.667, and that's equal to 35.9. Well, we need to get B by itself, and we have multiplication, so let's divide by the tangent of 31.667. Those will cancel out. Divide by the tangent of 31.667. And now we have B is going to be equal to something. Well, let's go back to the calculator. So we've got 35.9 divided by the tangent of 31.667. And we get 58.202. Move that right down there. Now guys, if that didn't flow real well for you, another way to think about this is in terms of proportions. As you can see, we've got, nice proportions here going on. If that's the case, that is absolutely fine. There's nothing wrong with it. This is the way I prefer to do it. So we have B as 58.202. We've got two of our sides. Hey, look at that. We have A and B. We could just Pythagorean theorem and find C. But for the sake of having fun, let's continue to use our trig functions. Well, once again, we can find angle B by subtracting 180 minus 90 minus 31.667. And that one I don't know off the top of my head, so I'm going to use a calculator. 180 minus 90 minus 31.667. We get 58.333. So angle B is 58.333. All right. Well, we have one thing left to solve for, and that's C. You can either use Pythagorean theorem or you can use any of our functions here. So let's use, I'm going to choose to use the sine of our B angle, or 58.333, is equal to our opposite side, 58.202, divided by our hypotenuse, or C. Now guys, just like the last one, if you want to think about it in terms of a proportion, that is absolutely fine. You can just think about this as over 1 and solve it that way. Or you can do the method that I prefer to do. Once again, multiply both sides by C, and we're left with C times the sine of 58.333 equals 58.202. And we can divide both sides by the sine of 58.333. Sine of 58.333. Those will go away, and we will be left with our C value. So once again, let's go to our calculator, clear all that stuff out. Let's go with 58.202 divided by our sine of 58.333. And we get 68.383. Move that right down there. And that is going to be our C side, 68.383. All right, guys, there's one more example on here. I'm not going to go through that with you, but if you would like to do that and have it ready for class, and we can discuss it. Have a good evening.